I'm going to cover the multi-core policy. So each, shut up, bird. Each core has shut up, bird. Adam knew his wife again, and she bare a son and called his name Seth. For God said, okay, so shut up, bird. Shut up, bird. I first called the task the Cain task, but that had too many freaky connotations, right? Cain and Abel. I called it that at one point. Adam's son is Cain task. I didn't want that. So somehow I think I accidentally forgot his son's name. I called him Seth. I thought Seth was his first son, but whatever. So the Bible is a very cool theme. Holy shit. Do you know how many names we can... if we need to name releases or we need to name... damn. It is the motherlode of marketing words. Anyway, so Adam is the father of all tasks, and Seth, Adam is the executive on core 0. Seth is the executive on the other cores. So why are there more than one? I don't know. Shut up. So technically Adam is a Seth task. You probably understand what I'm saying. Kind of ruins it. Sometimes it's counterproductive. I don't think so. Anyway, so I have a funny story. When I first started, I called it the root task. And I had a /root directory, just like I have a /Adam. So, do you see a problem? Put it in the root directory. Okay, so this is bad. To have a root task and have a root directory. No, no, no. You got to expand your mind. This is where genius... The Adam task. Okay. Sometimes, you know, that's kind of an interesting level of maturity. One day I woke up and said, you know, sometimes I should make a new name for stuff. Because in the past I always did this, and you might call it delicious bad naming. Anyway, so okay, now we got the Seth task. So why do we have an executive? What it does is it enters a server waiting for a message, I do believe, and it's actually sometimes this stuff seems depressingly awesome. Why? Because it's a Commodore 64. Okay. So you can make graphics. The sprites support flowcharts like this, I guess. Anyway, so there's a command user. Actually, this is, I lied. This image is not quite it's not 100% sprites. If you, I could be wrong. I do believe you can break apart the sprites. So we got links. Oh well, whatever. Are those buttons? Oh yeah, those are buttons. Okay. Anyway, user is how you. It's like system. User is like system. System, and you pass it some text. What does it do with the text? It enters. Oh shit. Okay. Oh well, it's right in the flowchart. Okay. It does this. Then it enters a loop where it takes a command at a time and compiles it. So that the system text, does it exit? No, it never exits. Once it runs out of system text, it starts prompting from the keyboard. Once you run out of, watch. So if I say user, and I say dir, let's just not even complete it. How about dir and no carriage return? No, I think we need, what is that gonna, okay, let's just do this. What? Oh, okay. Now, if you weren't paying attention, the windows always appeared in the same spot. And when I typed user, it did this. And then we hit enter and we get 2 characters. So you can say auto. This puts it in your own keyboard buffer. Shut up. What the fuck? Oh, I changed it. This is recent. Now this is called in because I'm a genius. Auto was in. I used to have auto files and the extension was AUT. Now I have in files and the extension is .in. That's because I'm a genius. Sometimes you gotta sometimes you gotta rename it. So in. So this is for your own keyboard buffer. Now the task have the let's just do this. FS points to the this is the task record address. Oh shit. Okay. Okay. So if we want, we can uh-oh. Okay. So we have his, you can send text to crosstalk. That's a we're going to send text to that guy. We're not going to hit enter. We're just going to say what? What? Oh, there it's it. Oh shit. You see the text right here? What? The cursor was in a bad spot. Okay. Now that we got that out of the way, so user is like system. It executes in a loop in the command. It's just like the system. And furthermore, it stays executing and doesn't exit. You can hit exit and it'll exit. Exe print executes the command line, and that's the end. It doesn't loop. Okay, so what does that mean? Is that correct? You know, there's a difference. I think it doesn't spawn a new task, does it? No. There's no new task. This is a new task. This is the same task. It just executes some. This is like system. this is like system, but synchronous in the same task. Or, well, it's hard to explain. Anyway, so that's lovely. This compiler is so easy to use. You can fire it up and turn it off really quickly. It's a fast startup, fast. It compiles. It's not an interpreter. It's really fast. If you say pop-up print, then you have, wow, this flow chart overwhelms me. I sort of know these routines. I use pop-up. I know what it does. But is this what it does? How is that different? Well, that's the point of this, is it's supposed to show how it's different. Pop-up is a lot like user. It's different though, and this is why. Okay, so this loop here is even though it doesn't look the same, it's pretty much the same. However, there's some added stuff. This just runs code, executes code. This searches for, this is a server command, or there's a name for this, like dispatch. You might call this a dispatch. Anyway, you can send commands to one of these tasks. You can tell them to spawn a task and start executing. You can tell them to just call a function. You can tell them to compile and execute some code. You can give, okay, these are all the message codes. Then you can send messages and text. Anyway, so the reason I brought this up was because these tasks are waiting. There's two things they'll do. They'll either spawn a task on the same core for you, or they will execute some code, not asynchronously, but synchronously. They will simply call a function and return. So the way you dispatch to Multicore is I really kept this small. So you either do job queue, which will I do believe this is a general purpose, but it's rigged. It's rigged so that you only do the first two, and you get a one-shot job that executes and is done. If you do spawn, this will either spawn on the same core. This will make a new task on the same core, or on a specific core. And we do not do fork. Fork and all that is ridiculous. Because this is a single address map. So holy shit. My chair just broke. It's had better days. So okay, you know what I should have done? I should have just stopped talking. You idiot. Spawn. Okay. How about, what do we want to call it? spawn my demo, and we're gonna pass it. Now this is pretty crazy. Okay. Shit. Okay. My task 1. So this is a routine. It has one parameter. This is standard. This is the standard out of the parent. These have one argument. They can return if you want, but never mind. So if that's the standard out, let's say doc print here. Okay, let's just see if this works. Okay, so it printed here. So what a bummer, my chair broke. Okay, so we're gonna print $$ foreground, comma %D $$ core %B $$ foreground. That turns it off. Okay, now we're gonna say FS. That's the current core. No, GS. GS num is the current core. That's for the color. GS num. That's the for the text. And you want to print a carriage? No, not a carriage turn. Let's put a space. Okay, so well, true. Okay, this is gonna be a terrible. You want to do full bore, full bore? Yeah, let's just do that. Have some fun. So we're gonna start on 4 cores. You can even start it on core 0, which is all applications run on core 0. Oh, what do we do here? What were you doing, you idiot? Okay. GS now. Okay, we're getting. Okay. There is no way out except rebooting because. Okay. I could be wrong. Are these children of? I forgot. Yeah, I think they're children. The only problem with killing this task, it's going to free this memory. And when that gets reused and corrupted, those cores are going to crash. So when I kill this, it will kill them, but it is more likely that what usually happens is these cores are running after the rug got pulled out from beneath them. It might die. Okay, let's see if we can analyze. I think it simply reused the memory for the code. Okay, what do we have? So when you get a crash, look at the RIP with the symbolic address. It says, you can look at the type of fault 32 debug. Okay, as a matter of fact, I don't know what the hell is going on. What that is a multi-core handoff. I think it crashed on one core and generated a message on this core. Yeah, that's what it's saying. We got a MP crash CPU number 1. I don't know if it's going to be friendly enough to help us. All of that code was yanked out and no longer has source debugging. It is no longer the same source code, so there really is no symbolic. It's invalid memory at this point. All memory is flat and open, so it's really easy to, you never have to worry about different address maps. So from what I'm told, there's this thing called System D or something. I don't know what it is. People are real impressed with. For my system, it's really trivial to translate a. It's not quite trivial, but pretty trivial to translate a. A number to an address. It's a very. It's not an efficient. Okay, system's been hosed. That's normal. It's Commodore 64 reboot. I would say about half of your crashes are fatal. You can look at the caller stack. You can. So there's going to be a reset switch on computers. It's just a different mindset. There's been propaganda to mock. Everyone's real excited about crashes. I put it this way. Well, this is not quite the best analogy, but Linux is a semi-truck with 20 gears. You need a professional license. It's got file permissions. Okay, Linux is a semi-truck. Windows is a passenger car. And TempleOS is a motorcycle. And you don't have side airbags on a motorcycle. If you lean over on a motorcycle, it'll crash. Does that mean the motorcycle is a defective product? No. Okay, DOS didn't have memory protection. Some people they stare at you and try to act stupid. Well, if it doesn't have memory protection, it's running in real mode, right? Fuck you. It's real mode. I don't believe you. If it doesn't have memory protection, it's real mode.